Mm. Mm.
Sanjay ji, I think we can start.
Yeah, so we have the other speaker have not joined us, I believe.
Sanjay, I think we're good to go.
Yeah. Good morning, everyone, and a very warm welcome to the international webinar on natural resource management using the geospatial technologies. And today we are going to discuss a lot about the application into the forestry, whereas the major thing that we have to discuss is the forest fire monitoring as well as the forest inventory control. So starting the webinar, I would welcome, and first I would like to thank Dr. Deepak Lal and the team of SWATs for extending the support to organize this particular webinar, and a lot of speakers have already been engaged by SWATs into this. First, I would like to welcome Dr. G. Linlin. Dr. G. Linlin, Professor Remote Sensing and Earth Observation, School of Civil and Environmental Engineering, University of New South Wales. Welcome, Dr. Linlin, to the webinar.
Thank you.
Welcome Dr. Lee Zia, Senior Project Manager, Piesat International. I'm still waiting for Dr. Lee. I would like to welcome Dr. Mukesh Kumar, Assistant Professor, Center for Geospatial Technologies, Higginbottom, University of Agriculture, Technology and Sciences. Welcome, Dr. Mukesh. I think he has not joined us so far. I would like to welcome Mr. Kamal Pandey, the engineer, scientist, Indian Institute of Remote Sensing. We are waiting for you, sir. I would like to welcome Dr. Tao Guo, our Honorable President, Piesat International. Further, I would like to welcome Dr. Deepak Lal, the Head Center for Geospatial, Sam Higginbottom University of Agriculture, Technology and Sciences. I would like to welcome all the participants into the webinar. Thanks for joining the webinar. I would like to invite Dr. Tao Guo to talk about Piesat, but before that, I would like to tell something about Piesat India. Piesat India is basically the international subsidiary of Piesat International located in Hong Kong. Basically, Piesat India is majorly responsible to take care of the existing business of Piesat International, where we are more into the software development, customization of the software and all. And many other things are there in the pipeline for the India business. I would like to invite Dr. Tao Guo to talk about Piesat International, its activities, strength, etc. Welcome, Dr. Tao, for the webinar, to the webinar.
Yes, thank you very much, Mr. Sanjay. So again, let me first thank Dr. Lau and team SWATs for the great support. And also it's our great pleasure to have Professor Ger from the from Australia. He is actually a very famous professor in the remote sensing society. So today we will have our pleasure to have him to give our talks. And here I'll start with a very brief introduction about the Piesat. Piesat actually is a leading satellite operation and application service provider. And we have an international headquarters in Hong Kong. I'm in charge of the international business in the Piesat. So we Piesat, we regard us as a service provider, basically. We start from the beginning, start from the scratch, develop our own system, remote sensing data processing system, we call the PIE, Pixel Information Experts. Right now, it's already taking leading role in the China. Hopefully, we'll provide this more sensing tools and also solutions to develop our companies to the Asian and other countries. And we are much focused on the software development. Another core, what they call pillars of business is the solutions. Based on our platform, we develop a lot of solutions like the remote, like the agriculture applications, forestry. Today we're going to talk, and water conservancy, meteorological. Okay, meteorological and the ocean. Lot of applications. Our solutions and the system has been successfully applied in China. Very large, very big scales. So that's one reason we would like to offer our solution technology to our what they call developing countries to share our experience. And very pleased about our company. Our company was listed in the stock market of Shanghai, not in the 2019 in the Star Board, like the Science and Technology Board. So right now we have 1,500 employees in our company. We have a lot of subsidiaries. Like in China, we have already 50 subsidiaries in every region, province, we call province in China. We also have international subsidiaries in Australia, Europe, and also, of course, India. So today, so it's our serious webinars. So okay, I will return the chair to Mr. Sanjay. Hello. Hello, I think Sanjay, your mic is mute. Okay.
Thank you, Dr. Tao. Now I would like to invite Dr. G. Lin, the Professor Remote Sensing and Earth Observation, School of Civil and Environmental Engineering, University of New South Wales, Sydney, Australia, to give a presentation over robust bushfire mapping with integrated optics and SAR satellite remote sensing.
Sanjay, I think before that we can. Okay, let's go ahead.
We have Dr. Lee Jia joined just now. Welcome, Dr. Lee.
Yeah. All right. You can hear me now?
Hello.
And also you can see the screen as well, my slide. Yeah. All right. First of all, it's a pleasure to be here with everyone and introduce our collaborative research with Piesat in information technology. So the co-authors of my presentation here is Professor Guo and Yu from Piesat Beijing. I want to start with a brief discussion about bushfires here in Australia. Obviously, it's one of the major disasters here in Australia almost every year, just to different extent, and then touch briefly in India and China. I must admit, of course, I know what is happening here because I'm living in Australia a lot, but perhaps not so much about the bushfire events in India and China. But I will try my best. Then we have two case studies I want to share with everyone. One is more than 11 years ago. So that was back in 2009 in one of our states, Victoria. And the other one case study was a more recent one. So in fact, it was last year here in Australia as well. The last part I want to just briefly talk about the Piesat system for bushfire monitoring and warning. So if during the course you can't hear me, then just let me know. So I will monitor my screen from here. But hopefully the technology will work for us. You know, when we try to do a webinar, it's always a challenge. It's the same as when we have to deliver lectures here at the university. I want to start with this quite recent, indeed, most devastating bushfire events here in Australia. It was lasted a good number of months, really. So it was between 2019 and 2020. I don't know how everyone have time to follow news events and so on. So if you switch on the TV back then, I would imagine that they would certainly have some sort of impression. But obviously here in Australia, that was pretty bad. It was known as Black Summer. And in total, 20 million hectares of land was burned. As you can tell from the picture over here, chances are that the kangaroo might not survive at all because fire is just everywhere. There's nowhere to escape. Nowhere is safe. On the other hand, if you look at this poor koala over here, you might have to wonder where's the food, you know, because the tree is gone and there's no tree leaves that actually the koala to survive on. Yeah, 3,000 homes destroyed. In fact, 3 billion animals were killed. So it's massive in terms of not only the economic, social impact, but also environmental, ecological impact, as you can tell. 33 people died. It's not as bad as the earlier event, 2009 event, in terms of the death. But here in Australia, well, I guess globally, every life counts, and we have 33 deaths. It's actually very devastating. There were a couple of American firefighters that died as well because of an accident in the firefighting. These are actually the words from our Indian colleagues. So I will tell you the name in a minute. So pretty much the bushfire is an inferno. It is a firestorm. And the scale obviously is quite large. And you can tell at that time the sky color is very different. And by the way, over here in Australia, in Sydney, my local time is a little bit past the 5 p.m. But of course, the sky is blue. But back then, you can tell it's deep orange. There are a lot of fire tornadoes, and hence why the damage is so much, and indeed the death as well as a result of that. What has been quite amazing is people, just like the kangaroo, like the koala I've just shown you, they have nowhere to go. They just have to congregate. They have to retreat to the beach and waiting for the Navy to evacuate them. So that was very devastating, as you can tell. Okay. For a long period of time, the city was just in very thick smoke. And it was for months, as I mentioned. Okay, it's not just days, weeks, it's months. So you can also tell the long-term health impact as well. So this was pretty much the wording that I was using by this over here. I don't know what this gentleman, I won't even try to pronounce his name, from India, whether he's in the audience or otherwise any of the people here in the audience know him. I think it's a very good article published in the Financial Express. So this gentleman is a CEO from iForest. I believe you might know the organization. So you can tell the scale of devastation as a result of the forest fire is actually very severe. And by the way, still many regions are still recovering from that catastrophe. So there's no overstatement on that, okay? What I quite like is the news article also have some very good thoughts about the lessons that we should learn from that. And indeed from pretty much an Indian perspective, if you like. Australia, we claim to be one of the countries that are best prepared for bushfires, massive events. But even that, guess what? That event, we can't do very much. There's only one thing we can do, is to pray for the rain gods to help us. And indeed, in the end, it was mainly the rain that get rid of the fire. So on that, you can tell if for any reason, and indeed with any technology, that we can find fires earlier and fight it earlier before they become infernal, then that always helps. And that's very much the central point of my presentation today. What has been quite important note here is obviously parts of South and Central India. You might have similar problems if it hasn't happened before, okay? So once again, I love that kind of attitude. We don't have to have that massive fire in our backyard. That's already too late. But we can take lessons from events happening globally. So what has been quite surprising is actually the last bullet point over here. Obviously, a lot of people still won't accept it, but in Australia, certainly after the 2019 and the 2020 fire, more people think there might be something to do with climate change. You won't believe a lot of people still say, you know, bushfire is bushfire, has nothing to do with climate change. Personally, I think there will be strong correlation between the two. Obviously, common sense is that when you have climate change, the fires will be just more intense and more frequent, as indicated here. It sounds like in India, that might be the case as well. So the number of fire events, forest fire events actually doubled from 2015 to 2019. In China, the firefighting is quite a different attitude, and to some extent, I actually like the Chinese way of treating bushfire better, because in Australia, sometimes we have this perhaps risky strategy and say, you know what, we only contain the fire, we don't necessarily want to put off the fire and stuff like that, because, you know, it's part of the process. You want to reduce the fuel on the ground, and sometimes we actually have controlled fire burning and so on. But in China, I guess, wherever there is fire, they want to put it out as quickly as possible. So this is one of the fires. back in April 2020. And of course, once again, I'm hoping that we have some sort of neutral ground on that. I don't quite like the way in Australia we manage fires. As I said, they kind of not really fight the fire, rather only just to contain it. But in China, perhaps sometimes we put firefighters' lives in danger because we really want to get on top of the fire. Sometimes it's just too fierce. We can't really risk that. But anyway, so that's an argument, that's a debate we can have on another day. Let me go on to the two case studies. I want to start the earlier one. So 2009 Victorian Bushfire. As I foreshadowed earlier, this fire is much more deadly than even the most recent one. So instead of a few dozens, it's actually 173 people died as a result of the fire. And the area is quite extensive, although not as extensive as this more recent, the 2019 and 2020 Black Summer Fire. We call this fire actually Black Saturday Fire because it started on a Saturday in Victoria. Before we have the recent fire, it was the worst in Australia, obviously. Right now, the worst is the 2019 and 2020 fire. Okay. Something that I'm very proud of for us as a team, as researchers, was back then we will manage to use a couple of Chinese satellites to map the fire from the very beginning to very much the very end. For many of you, you might need a little geography help here. So Melbourne is the second largest city in Australia. My organization at University of New South Wales, as you can tell over here, is mainly located in Sydney. We do have campuses in other cities such as Canberra, our capital for the country. So the long story short, back then was that Chinese satellite was brand new. It's actually been tested in orbit, but I had a little help from the embassy of China in Australia. So the ambassador was actually visiting our university, and I had a very important discussion with them. I said, well, we have this massive fire over here. I know that this Chinese HJ-1B satellite was a perfect satellite to map the fire, and they actually mobilized the satellite to capture the image. So it was on the second day of the fire, then the system was activated. And as you can tell on this one over here, you can even tell the difference of different fire fields, how they are going. For those sharp eyes, you can actually tell this fire spot right over here. And we can talk more about that. And in fact, if I zoom in a little further, we can see smaller, even smaller fire spot over here. And that's part of the argument as well that I will speculate a little later on. Before I do that, I do want to acknowledge multiple agencies that was part of the exercise. I was a member of a major national research center over here, the CRC for Spatial Information. UNSW is my university over here. The government agency and a few agencies in China, you know, when you have to use the satellite in real time. This is the kind of teamwork that you would expect. So the National Disaster Reduction Center of China, the operator of the satellite, so CRESTA, and also the Chinese Academy of Sciences, they actually run the satellite ground receiving station. So it's a massive undertaking, as you can tell. And of course, the ambassador was very pleased to see that actually worked out. If you look at the bottom left corner over here, you might think that all those are thick smoke. Well, that was my impression, first impression anyway, as soon as I had the result. But guess what? That was not true. It's actually cloud. So this is quite amazing, isn't it? When you have a massive fire, you also have cloud cover, and immediately we'll think, oh, okay, is there a better way of doing that? And hence the second part of my talk. As it turns out, if you use near infrared, in this case, shortwave infrared, or just the visible remote sensing satellite, you will have the same problem as I'm having here. And in fact, for this 2009 bushfire, guess where is actually the worst affected area? It's actually right over here around King Lake. That's the epicenter of the event. But unfortunately, because of the cloud cover, we can't really see what is going on. The only thing we can see over here is actually in the gap of the thick cloud. So you can see the fire over here. But guess what? The whole area around here is actually on fire. But anyway, we'll see some of the stuff a little later on. Something that I want to point out and indeed highlight the importance of having intelligence such as this one over here from the satellite is you can pretty much tell the difference between those two fire fields. At the Darga over here, only the fringes is burning. The central part has been controlled. The fire has been put out. So in that case, we call this the contained fire. This is actually a running fire. So you can tell it's still ongoing and out of control. As I said, if we can have the exact location of a spore fire such as this one over here, then it will be a very different story. And that's why for more than 10 years, I've been promoting this proactive firefighting over here. Remember my sort of difference of strategy in terms of how we really need to manage fire over here, because the fire water is so bad, you can't really allow the fire to spread. So the earlier you can detect small fires and indeed to get rid of it with massive machines such as this guy over here, then the better, the less likely that you'll have a catastrophe down the track. Okay, so we have many waterbombing helicopters here in Australia. Some are from the private sector, others are actually maintained by the government. So typically they are around the kind of 1,500 liters capacity in one go. But just look at this magnificent machine over here, the air crane. We don't have any for Australia. We typically rent that from Canada, from the US. So they can actually hold as much as 9,000 liters just in one go. And of course, have that in less than 2 minutes. Typically, it's 90 seconds that it will fill the tank. Okay, so it's 6 times as more powerful as our usual waterbombing helicopter over here. So my argument is, if you have the intelligence, if you can feed them, if you have a wonderful management system in place, then you can actually get the air crane to the right place at the right time, and indeed with the right amount of water, and get rid of the fires before they spread to massive fire fronts. Okay. So as I said, the fire started on 7th of February 2009. And on the second day, we have the first image. And ever since then, it's almost every day that we'll have an update from the Chinese satellite. So it has been reported extensively, not only here in Australia, but also in China and indeed globally as well. So that created some sort of a very positive message, not only for us as an organization, as researchers, but also for the space sector, for indeed the back then the very friendly relationship between Australia and China. Okay, so as you can tell, the fire at this scale, you can't see a lot of detail because obviously we want to cover a large area, and indeed the coverage of the single images is huge. We're talking about 720 kilometers with a single frame. So it's a very capable satellite. And of course, you can tell that there are massive fire fields at a lot of locations. In fact, on the first day, guess how many fires are were there. It's more than 400 fires all at the same time. So sometimes people argue with me and say, well, you know, we have a lot of aircraft that can map the fires. I say, well, if you have a fire season, as we used to call here in Australia, then pretty much you do need the spaceborne remote sensing to back your airborne remote sensing, okay? Otherwise, you will stretch resources to the very limit. Let's have a few zoom ins. So the first one is going to be here. That's very much the epicenter of the fire. And then we'll have a zoom in around there. We'll have that active fire. So waiting for you to see how it started over there, massive, and then just get controlled. And then let's look at the bottom part over here. And each of that is actually quite a large far field. As I said, you can only appreciate that when you zoom in. Let's look at the first one. So as I said, the epicenter, the worst affected area is actually King Lake and the Marysville. So in fact, Marysville over here is right in the center. You can use, Melbourne is somewhere over here. You can use that as a reference, okay? So the reason why in the middle over here, you don't see any information is because of actually the cloud cover, okay? So as the fire started on 7th of February, and also on the second day, 8th of February, cloud cover was over there, and you can't really extract any information, unfortunately, from the optical satellite. But the fringes, we've been lucky, so we were able to see how the fire evolved and stuff like that. Just look at the scale. So from here to here, this is about 100 kilometers. So over here, we're talking about roughly 150 by 150. So massive, massive fire. As I said, unfortunately, in Australia, that happens almost every year. It's just some years are very, very bad, like 2019 and 2020. Other years are a little better, such as this year. But this year we have a different problem. We have massive flood, and indeed, as we speak, my team is working on the flooding event. So, you know, you never get an easy go, isn't it? This is the Beechworth fire. So we actually had a very good first go on 8th of February, because we don't have a cloud cover over there, and we pretty much captured the whole fire field. And then later days, obviously the firefighting has been quite effective, and only the fire managed to expand a little bit. But you know, something that you can tell straight away, because of very strong wind, the fire can easily fly over dozens of kilometers and indeed ignite another area. And that's the danger. And hence my preferred strategy, I say, well, get rid of the fire, the earlier the better, instead of say, well, try to contain it, wait and see. It doesn't work, okay? So, but anyway, that's only different opinions over here in terms of how to fight bushfire and how to manage the fire. I don't know whether you can see anything that is quite urban normal here, because if you look at over here, we actually have the kind of a fire detected over the ocean in the bay, okay? So the yellow line is actually the boundary between land is over here and ocean over here. Obviously, this is a bay area. The reason, well, you might have imagined already, it's because of the strong wind. So the wind is pushing that way, and hence the spread of the fire. When it arrives the edge over here, guess what? The hot air plume actually was right above the water. And of course, there is a kind of false information that the water is burning, but we know it's not. It's just the hot air, extremely hot air that was picked up by this thermal sensor. That's another side, another aspect why we need a different sensor to look at the problem, look at the disaster, and hopefully we can pin it down on the ground level, okay? So perfect timing for me to talk about. Indeed, immediately after 2009, we proposed that we actually need to combine radar satellite and optical satellite in order to do a better job to measure fire. Number one is actually we can penetrate the cloud. The other is actually we can just see the bush, the impact of the fire on the bush, on the ground, instead of just in the air. Otherwise, we will have misleading information because of the hot air plume, as I mentioned earlier. Okay, so what we have been since 2009 developing, and I'm very grateful that Piesat actually came on board. We have an ongoing project to do that, is to explore this brand new approach. So we know that bushfire is not your ordinary fire, because if you do not have bush, you do not have bushfire. And of course, right now, a lot of the conventional wisdom is just focusing on the fire, and of course, in fact, the high temperature as a result of the fire. We say, oh, let's look more on the other aspect, which is bush. And we know that radar, synthetic aperture radar, the imaging radar in particular, is a brilliant sensor to look at the bush. And another advantage of radar is it is all weather, and you can take images anytime. Okay. Again, I don't want to go to too much technical detail. Pretty much my PhD study and most of my research career is about the two guys over here, interferometric synthetic aperture radar and a differential interferometric synthetic aperture radar. We're still very strong in that area. We're one of the leading groups in those areas too. But I've been always looking at this coherence issue. So again, in the long technical sense, coherence is just measure the similarity between the two images. It's just a correlation on a kind of pixel by pixel basis, okay? So you work with one image collected before the fire, and the other is when the fire is ongoing. I had that idea back in 1995, so long time ago when I worked on a Japanese earthquake, okay? So right now, of course, we try to apply the same idea to a lot of other natural disasters, bushfire, flood. Okay, so here is a case study that we actually put that into action, not just an idea anymore. As I mentioned earlier, this is not really the thing, the major fire we're talking about, the 2020 Black Summer fire. It's not part of it. It's actually a fire much later, because it was almost towards the end of last year. Obviously, we have, or the agencies here have learned a lesson from the Black Summer fire, the bushfire, and they try to do a good job. They do a lot of controlled burning or otherwise a hazard reduction. This is the location over here for those who have been in Australia. This is our lovely international city, Sydney, okay? And by the way, the international airport right over here. You might know another city to the south of Sydney as well, called Wollongong. So our test site is right over here. Our forestry department, I guess many in the audience, you are from that sector as well. They were actually doing a control burning, the hazard reduction burning right over here. They just want to, burn the dry leaves, the dead tree and branches on the ground and stuff like that. But guess what? Very often, things like that will get out of control. And in this particular case over here, it did get out of control. So a very strong wind, unexpected, pushed the fire this way. And as you can tell over here, it used to be a lovely green, dark green, the forest, but then all this disappeared, destroyed, and you can tell the bare ground over there. And indeed, the fire is still going right over there at the fringe. And it started a new fire over here. So if you compare those two, then the bottom one is obviously still ongoing. The top one, the upper one was contained. Well, this is from the true color, okay? And we're using the European satellite, Sentinel-2. It's a multispectral satellite. If you look at the false color combination, the fire condition is even more better understood. So you can tell this is the controlled burning that was initially started over here and get out of control. And over here, as I said, the two fires are slightly different in terms of different stages. Contained over here.
Dr. Lilin, sorry to interrupt. We are running short of time. Would request if you can complete the presentation faster.
Sure. Yep. I'm very close to get it done. Just give me a couple minutes. Yeah. Thank you for the reminder. Okay.
Please continue. Please continue.
Yeah. So as I said, we really want to do the radar. So this is the radar part. And we have even a baseline information. So that's 2 images taken before the bushfire. And this is one before the bushfire, one is while it's ongoing. For those who are doing remote sensing, you can tell the difference straight away. So this is actually because of the vegetation decorrelation, the same on the 2 images, but this is actually a different one. And guess what? If we take the difference between the 2, and we can highlight the fire, and there you go. It's right over here. You might be asking, how about the bottom one over here? Well, as it turns out, the 2 images, the 2 satellites are running at a different time, just a 1-day difference. So this is 11th, and that's 10th. And hence, this obviously started on the 2nd day, 11th. Okay, you can tell this has huge implications because we can obviously do a much better job with the radar. So it's still an ongoing collaboration between us and Piesat, and we're hoping to get the job done in a matter of just a few months and make it operational. I want to use the last couple of minutes just to introduce the Piesat system to everyone. And obviously, it has been an operational system for a good number of years now. And the update is once every 10 minutes. It's using a combination of geostationary satellite and also a lower Earth polar orbiting satellites, plus real-time in situ monitoring cameras, as you can tell over here. So it's a very comprehensive system. It can even take on field reports as well. So obviously you can rely on the system to support not only monitoring, but also the warning and also decision support, okay? So just a quick note to wrap up on my talk. Obviously, right now there are more and more satellites coming online, and we're looking forward to collaborate with everyone, in this audience here, and hopefully we can also work on some fire events, not only here in Australia but also in India, in China as well. So with that, I want to thank everyone for listening to my talk. And I'm happy to take some questions if time allowed, or otherwise later on at the panel discussion.
Thank you very much, Dr. Lilin, for
thank you, everyone.
The presentation that we all saw is full and having a good number of facts and figures available. That makes it very much real, and people get a lot of information about what exactly is happening over there in the country. And as well as the presentation that we saw also tell us that how much potential is available in the country, in Australia especially. And it's a golden opportunity for those companies like Piesat, who are having such kind of services like forest fire monitoring services and all. They can have a good start there in the country, in Australia, nearby places as well. Thank you, Dr. Lilin. Dr.
Thank you.
Lilin, very much for your presentation.
Thank you.
Now, before I invite, I would request Dr. Deepak Lal to introduce Sam Higginbottom University of Agriculture, Technology and Sciences, I would request Dr. Deepak Lal to talk about the university, its strength, its current activities of the university. Dr. Deepak Lal.
Thank you, Mr. Sanjay. It was a great presentation by Dr. Linlin. I really appreciate all the information that were provided in your presentation. Here, understanding that we have a short time, so I'll just present you a very brief profile of Sam Higginbottom University of Agriculture, Technology and Sciences. In short, we call it SHUARTS, and it's situated in the city of Prayagraj. That's the newer name. The old name was Allahabad in the state of Uttar Pradesh, India. Um, and this is just a juxtapose or a collage of some of the buildings that we have in SHUARTS. The light green building is the management building, management and business studies. The red color building is the engineering building. The white color building is the biotechnology and bioengineering. And then we have some of the portion of our administrative block. And as you can see that on bottom left corner, there is a saying written in Hindi, Siksha Manushya ki pravritti ko mukt karne ke liye hai. In English, it translates that education is to set human nature or character free. So very profound saying, and we all like it. We have seen it since we were studying here, so it has a very good memory with us. So we'll just start with a very brief profile. Um, it all started in 1910, almost 120 years ago, when this gentleman called Dr. Sam Higginbottom, he arrived in India as a teacher of economics. So he wanted to teach people economics, and realizing the fact that the soil and the conditions were very encouraging, and they were very fertile for crops, he thought that he would establish agricultural institute here, and that's where it all started. So he started this institute in 1910, and this very institute was a pioneer to offer in degrees in agriculture engineering in entire Asia, and then fourth in the entire world in 1943. The first degree program started of agriculture engineering. Then the SHUARTS is spreaded more than 600 acres of lush green campus on the banks of River Yamuna. We also have some off-campus areas around 400 acres. Then we have 14 colleges, institute, 58 departments covering agriculture, sciences, engineering, humanities, health sciences, and other degree programs as well. We have more than 2,000 teaching faculties and non-teaching faculties altogether. Then at this time, we have around 13,000 students enrolled in 47 undergraduate, 104 PG programs, as well as PhD programs. Then some of the dates which were important for our university in year 2000, on March 15th, the Honorable Minister of Human Resource, he declared the institute as a deemed university. And then we gathered accreditation from various agencies like ICAR and ICFRE. Then we also have NAC and UGC accreditation. And then we were placed in A grade deemed university by MHRD in 2014. Then it was in 2016 when our university, or the deemed university, was granted as a full-fledged university status in 2016 by the state. Talking about agriculture, because that's where it started from, so we have a world-class seed breeding program in the university, and they have already released various varieties of the seeds which are more temperature tolerant, drought resistant, and short duration than the conventional ones. And this is what is the need of the hour when we are having a very scarce rainfall and the temperature are rising, and it's altogether it's pretty unstable here. Then we are an ISO certified university, and we have association. We are members of Association of Indian University, International Association of Universities, then Christian Higher Education, then Asia Pacific Association of Agriculture Research Institutions, then Global Consortium of Higher Education Research for Agriculture, and many other. The university has signed many international MOUs on academics and research collaborations. The institute has completed over more than 120 years, and our vision and mission includes gospel and plow, and the motto is feed the hungry and serve the land. And we strive to achieve newer heights under the dynamic leadership of our Honorable Vice Chancellor, Most Reverend Professor Dr. Rajendra B. Lal. So that was a very brief profile. Let's see some of the recent, not activities, but I would say that there were some things which recently happened, which was really encouraging, at least as when we consider the past year, it was really heavy on all of us, entire international community. But we got this Education Excellence Award recently, and this was based on the service that we have been offering to the country, to the international community continuously, and especially our efforts were recognized by the state government, that how we contributed during the lockdown period. We were one of the first institutes that we started online education. I think the lockdown happened in last March in our state, and in April onwards, we started delivering lectures and helping students online. All the practicals were done online. I mean, obviously not the wet practicals, but the dry ones. They were shown modeling through the system, and we made sure that whatever we can provide through online to students, to our students, to our researcher, we should do it. So modules were prepared, lecture notes were delivered online, and even the examinations were taken online. They were online proctored examinations. So our effort was not to delay the session, and eventually the session went well on time, and our students graduated on time. So recognizing those efforts, we were awarded this Educational Excellence Award. And then we were recently we also got a news. This gentleman called Mr. Francis, he was a student of our BTech Agriculture Engineering program, 1998-2002 batch, almost 20 years ago. And he has been appointed as the governor of one of the provinces in the country Republic of Rwanda. And I fondly remember him. He was just my immediate junior. And I fondly remember, discussing with him various political matters about his countries, about our country, and so many things. I have fond memories. So it was great to see that he has become now the governor of one of the provinces in Rwanda. And we feel that we are blessed, we are fortunate enough to have so many alumni like Mr. Francis, who are contributing in not even in India but entire world in various capacities. And this is a small map that I would like to show, that we have alumni's presence worldwide, and they are contributing in their own capacities. And we hope that the motto, the vision, mission of SHUARTS is carried over again and again in near future, and it's all for the community. So with that, I would like to end this presentation, and I would like to invite our next speaker, Dr. Mukesh Kumar, who is an assistant professor in the Center for Geospatial Technologies, SHUARTS. And we recently, one of our article got published on forest fires mapping. So I think it's going to be another interesting presentation. So over to you, Dr. Mukesh.
Thank you, Professor Deepak Lal. First of all, I would like to thanks all the participant dignitaries of the webinar who is attending it, and my dear friends. Very good afternoon to all of you. So I would like to request you to allow the screen share so that I can. Okay, thank you. So the topic which I am going to deliver for today webinar is the forest fire risk mapping using AHP and Earth observation data set, a case study of mountainous terrain of Northeast India. This article has already been published recently in the SN Applied Science. It's an open access journal. It's come under the Springer link. So I would like to request you all the participants to download this paper and go through it to understand the mapping of forest fire risk zone. I would also like to thank all the authors or researchers who have contributed to do the forest fire mapping and published in successfully in a good international journal. So as we know that the most common hazard in forest is the forest fire. Dr. G. Lelin already have explained about the different types of forest and what different in area, how it is working. So from last few decades, forest fire is become the critical issue globally, which caused the major concern in biosphere and the atmosphere interface. And forest fire has adverse impact on the environment, forest ecosystem, human activities, biodiversity loss, soil erosion, properties loss, and even the ultimately it affects the human health as well. So as per report of Forest Survey of India, approximately 64% of the total forest area is frequently affected by forest fire, which caused the economy loss of approximately 60 million US dollar. About 90% of the forest fire in India is caused by the human. And if you look to the Northeast India, it is mainly due to the shifting cultivation, that is also called the zoom cultivation, where people of this area is doing the cultivation by cutting the forest tree, by burning it and doing it. So that is the main reason. So anthropogenic activity is the main reason for the forest fire. So it is very important for scientists and researchers to map those areas which is prone to the forest fire. For this, remote sensing and GIS techniques is very important techniques to map the forest fire area as it gives us the special information in the regular basis. So this is the map. It's been taken from the Forest Survey of India. So we can see from the figure 1 that Northeast India and central part of the India is more prone to fire, and this area is more affected by the forest fire. And the figure 2 clearly indicate that the high forest prone area or highest fire prone area, highly forest prone area is mainly in the northeast part. Like Northeast India is like Arunachal Pradesh, Assam, Meghalaya. These are the area which is having more forest fire. Also, as for the report of the Ministry of Environment, Forest and Climate Change, that number of forest incident in the central state and northeast state of India is very high. So considering all this background, we have decided to identify the forest fire risk zone, map the forest fire risk zone in Rayo Voi district of Meghalaya by using the AHP and Geospatial technologies. So this is the study area of our study, that is in Meghalaya, the Rayo Voi district. We can see the different climatic condition and the elevation population of this area. So our objective was to map and to find out what are the reasons behind it for the forest fire. So we have used the software ADAS imaging, ArcGIS and Microsoft Excel to map this type of area. Data used in this study is mainly the open source data like MODIS data for the fire point, which give us the fire point data of any part of the world. So, and the ESTA data we have used ESTA DEM used for the elevation, slope, and aspect, as it play a very important role for the forest fire. And then we also use the open source database Landsat for the land use land cover mapping, and then the meteorological data like temperature, wind speed, and rainfall. All the data is open source data. So it is also good for the current researcher to work with the open data source to identify the forest fire area, to find out the reason what is going behind and what are the main reason for the forest fire. So they can use the data. We have a number of forest data, forest fire data, or like different types of data freely available. So this is the overall methodology of this work, where we have taken the satellite data, then meteorological data, ancillary data, and then the MODIS data for the fire points. So satellite data like Landsat has been used for the land use land cover classification, types of classes in that particular area. ESTA DEM has been used for the elevation, slope, and aspect. And then we also have used the meteorological data for the temperature, rainfall, and wind speed. And that as this area is forest fire in this area is mainly due to the anthropogenic activity. So we also considered the census data. That is one of the most important parameters used in this study. And then all the database has been created in the GIS environment, and then Ahp techniques, analytical hierarchical process pairwise techniques has been used to assign the weight to the different thematic layer as well as the different sub layer. And then forest fire map, zone map has been created, and it has been also been validated using the MODIS fire point data. So these are some of the maps which has been created during this work. For example, like population density map, land use land cover map, elevation, temperature, slope, and aspect map by using the different data sets, and then population density and rainfall maps. These, after creating all these thematic maps, Ahp method has been used to generate the pairwise comparison matrix using SETI's 1 to 9 scale. On the basis of this scale, different weightage have been given to different thematic layer which has been used in this study. So these are the different stages which has been followed. I would like to, as we have only 10 minutes time to explain all these things, so I would like to request you to go through the Ahp techniques. It's not very hard techniques to find out the weightage of different layer. You can find it directly from the Google also, the calculation, or you can read this paper that will help you. As I hope that most of the participant is from the forestry background. Even if you are from the different background, this technique is important to find out the weightage. So on the basis of Ahp, we have find out the normalized weight of different thematic layers. So it is very important to know that which thematic layer has more important. In our case, like population density is more important because that zoom cultivation, shifting cultivation in that particular area is important. In other part of area, maybe the land use land cover is important, somewhere elevation is important. So you should have to have knowledge of that particular area if you are working in different part of the world. Similar techniques has also been used for the subclasses, and the weightage has been given to different layers. So this way we have given the different weightage to the different layer. and then the final map has been prepared by adding all the weightage in the GIS environment, and we come with the conclusion that most of the area, like approximately 33% of the forest area is come under the high risk of fire, and approximately 24% area is come under the high risk, and 33 is very high risk area, which has been mapped it here, and some modis fire point has been overlaid and validation has been done, and we come with a very good result of validation. And then we also can say that we have identified the area which is prone to the forest fire. So our conclusion is that GIS, and by using the Ahp techniques, GIS techniques and Ahp weightage analysis is very good techniques to find out the forest fire risk zone of the area, because until or unless we don't know that which area is prone to fire and which type of action and what are the main reason behind it is very important to know. So for that we need to map the area which is prone to fire. So like in this region, in northeast region, not only in Meghalaya, our study area, but in northeast region, anthropogenic activity is the main reason for the forest fire. So our suggestion for the government of India or from the some organization which is working in this section is to aware to create some aware program which will help the local people to find out the alternative of their livelihood to stop the forest fire. And then like I also like to say that in different part of the world, the forest fire region of forest fire is different, but the mapping is very important of area, because once we identify the area which is prone to forest fire, we can go for the strategic point. So from this conclusion, I would like to stop it here, and thank you to all the participants, and also like to thank the Piesat who give us all the information and platform to deliver the talk, and also like to our energetic head and dean who give us opportunity to work in the forest sector, as I am the forestry background researcher. So it is good for us, and also have done my study in that area, northeast region. So I can understand it, that how the forestry problems are existing in this area. In this word, I would like to thank you all to listening this this topic of forest fire. Thank you, sir.
Thank you, Dr. Mukesh. This is really a very informative presentation you just presented, and we can see that the conclusion that you discussed, where I can personally see that the major reason for the forest fire in our country is the man, the human beings. So I believe that company like Piesat, who's having the forest fire monitoring kind of platform, which can help us, detect the fire as early as possible, and the forest fire monitoring platform gives the result in every 10 minutes. And apart from that, I would also request the developer of the platform to at least have some research and add on a point, add on a feature where we can monitor the trespassing also, so that it becomes very easy to identify that when and who is entering into a particular forest across the country, and based on that we can stop it, so that we can stop the fire.
Thank you, Sanjay Singh.
Thank you, Dr. Mukesh. Thanks for your presentation. Now I would like to invite Dr. Lee Jia, the Senior Project Manager, Piesat International, to give a presentation of our geospatial tools and techniques for forest management. Dr. Lee Jia.
Yeah. Okay. Okay, thanks to the host and the experts and other colleagues. Now, I will introduce some applications about the forest resource and some investigation and supervision project. Now, my presentation is divided into 5 parts. Now, the first is about the forest resource inventory and forest resource monitoring. And the third is about ecological projects. And the fourth is about wetland resources monitor. And the last is about the forest health. So it's about the forest damages. Now, the first is about the forest inventory. Okay, next page. Next page. Mr. Ma. Mr. Ma, can you transfer the page for me, Mr. Ma?
Seems to have some technical issue.
Okay, this is. Okay.
हिना दीदी बोल रही आने वाली है।
Hello, Dr. Lee.
Hello. Okay.
Would you want me to?
Okay. This is. Now the first is about the forest resource inventory. The first forest resource inventory is sometimes very important to the forest department in our government. Our government will launch about the 10 years and 5 years inventory about some forest resource project. And we usually call the first class inventory is about the national scale for the forest resource inventory. And the second class inventory is just about the province scales about the forest inventory. So we use some the remote sensing data and some technologies to finish this job. And we now in order to give the very good and very good result and products, we use sometimes in our project we use objective segmentation method to give some forest classes. This map shows our the methodologies about the object segmentary. The object segmentary is can be used to achieve accuracy statistic of forest land. The image is very specific time and obtain the change the forest land in different periods so as to achieve the purpose of forest land change and detections. Okay, next page. Yeah. And we also use some high resolution satellites images to give the second class classification about and we use a different method such as low texture information added modeling regardless of the tree species. And the second method is about add the texture information modeling regardless of tree species. And the third is add the texture information tree species model. With the three methods, we can find that the best precision is about the third method, and with 72% of the result. And we also use some sports data or the other Chinese satellites images. Okay, the next page. We also use a laser radio data to modeling the forest height. We use the later data to get the canopy layer of the trees, and we also use DTM digital terrain models to get the DEM. So we use the CHM and the DEM to get the height of the tree. Okay, next page. This is some result about the forest tree height variations. Okay, the next page. Okay, we'll also do some forest land changes, some land use change, or some land cover, some forest cover changes. We use some Chinese satellite state with some 资源 3 or Gaofen 1 date. Okay, next page. And we also do some assessment on the ecological protection project, on some conservation about the forest or conservation on the grassland. So we monitor the forest vegetation coverage in the Anji County, which is a Chinese county in Jiangxi province. And we gave the forest vegetation coverage different levels. And we analyze the change before the project start and the project end. Okay, the next page. We also do the some monitors about the ecological engineerings, and with the distinct protection areas about the wetland, and the other to increase the significant ecological efforts. Okay, the next page. We also monitor and detect the urban green resources. The green resources in the some remote sensing data can be reflected by the green. Okay, so we use the band of green to reflect the green resources areas and give the very high resolution map. Okay, next page. Next page. Next page. Mr. Ma, can you give me the next page?
Can you tell me the number of the pages you want?
11.
Okay.
Page 11. Okay.
Yes, we are on page 11. I'm sorry. You can continue.
Okay. 11. Okay. It's about 12. Maybe the 12. Page 12.
Yes, this is page 12.
Okay, but my screen is not change the page. Maybe this is the let the
Yes,
network problem.
yes, probably due to the latency. You
Yes.
can proceed because this is a consistent flow of your original slide. So you should be, yeah, you can proceed now.
So maybe yes, maybe I can. Uh, okay, can I give some other page and
Mr. Ma, you can reshare the file again.
okay, I will reintroduce by myself. Okay, thank you. Okay, the next about the forest damage. So we also do some project on the pets about the forest with some the optical data or some hyper optic data, and with can reflect the forest pates and the forest damage, because the forest pate or damage have some symptoms with the leaf. Sometimes some pates can reflect so the red color or the black colors. So these symptoms can be reflect on the satellite band. So we also do some project about the forest pates and forest damages. Okay. And we also do some monitors on the wetland resources. Wetland resources can have some the water areas and the water areas change and the water volume change with some DM date. We can monitor the wetland water change and the water floods. Okay. Okay, that is all about my presentation. Thank you to all of you. Thank you. Okay. Thank you, host.
Thank you, Dr. Lee. Thanks for the presentation. And through your presentation, we exactly come to know about the 5 aspects of forest management, where very important aspect that you discuss about the resources into the forest of any country, which are basically the wealth for the country, which should be monitored well to understand that how much and what kind of wealth is available into a particular forest of the country, so that that can be monitored well and can be utilized by the government of the country further. Thank you, Dr. Lee Jia, for your presentation.
Okay, thank you.
So now I would request Dr. Deepak Lal to take over and invite all the speakers, the panelists for our expert talk, which is over the remote sensing and GIS for forest management. And along with that, I would also request all the participants, if they are listening to me, to keep all your questions ready, and you can directly ask the question. But before asking that, you have to raise your hand over the chat so that specific questions can be taken, and you also have to write down the name of the speaker so that we may ask your question on behalf of you to the respective speakers. Dr. Deepak Lal, over to you, please.
Sure. Thank you, Mr. Sanjay. We have a group of specialists here who have presented their work, and now I would like to invite them for a expert talk. First of all, I would like to invite Dr. G. Linlin and Dr. Mukesh Kumar, Dr. Lee, Mr. Kamal Pandey from Indian Institute of Remote Sensing, Dr. Tao, President of Piesat International, and our invitee, Dr. Pandurang Chaudhary, Assistant Professor, Department of Geography, University of Mumbai, Maharashtra, India. So, welcome you all. And,
Thank you, sir.
and we are very fortunate enough to have you all. And so, what I have done is to discuss various aspects. I have selected few common questions, which I think I'll be asking on behalf of audience, or we will be discussing even their questions as well. But to start with, first of all, I would like to discuss that what are the various aspects of forest management. So maybe we can start with Dr. G. Linlin. What are his views? What are the various aspects of forest management? When we talk about forest management, what does it involve?
Well, I will try to keep it brief. So in Australia, obviously, the forest management, a lot of the work is around the area of bushfire. So before the fire season, we have to have a hazard reduction burning. And of course, during the fire season, massive undertaking, a lot of resources, airborne firefighting resources and stuff like that. Post-fire, there's always a chance of, landslide and stuff like that. Unfortunately, this 2020 and 2021 is a very typical example. So severe flood following the massive fire. So in that sense, I think even the soil part will come into play. So I guess the most important, obviously, is hazard reduction. How we can keep the fuel load at a reasonable level in order to minimize the bushfire risk. Yeah, back to you.
Okay, thank you, Dr. Dr. Linlin. How about Dr. Mukesh? What are your views about the forest management?
As Dr. Linlin explained about that, management is something like until unless we don't have the information and places where to go for the management, and proper strategy is required. So it is very important for us to identify the area and find the reason. What is the reason behind it? Is it some anthropogenic activities, or because of the lighting, or because of the slope? What are the reasons? And accordingly, we can go for the management practices. So for the area, like as I have already have explained, in the northeast area, if the northeast part of the India, as we have the mainly cause of forest fire is the anthropogenic activity. So why people are doing this type of things? Why people are doing the fire? Why they are cutting the tree on for the sake of their livelihood? So we should have to uh, the alternative to them to go for their livelihood. Uh, Government or some good organization, international or national organization, have give the opportunity to the local people or tribals to do some livelihood activities, and then in this way we can manage the forest. So area wise globally it differ how to manage the forest. That is all about my opinion.
Sure.
The forest management.
Sure. Dr. Chaudhary, would you like to share your opinion about forest management?
Yes, sir. Yes, sir. Yes, sir. Why not, sir? Actually, basically, your question is what are the various aspects of forest management? So, if we see in our India from ancient time, or maybe you have gone through that various toposit which is made by that Survey of India. So, if we see that there are a lot of reserve areas are there, and from that, in our India, there is a tradition we are protecting our forest to fulfill our that livelihood. Then if you see that we are protecting our forests through that making that that is a reserve forestry, or maybe social forestry, or we are doing afforestation in that areas where we are cutting that forest trees. So in the forest management, social forestry or reserve forestry or protected forestry, these are the concepts are very important. We can protect our forest through this type of the concepts.
Sure, sure.
Yeah.
Sure. I think what we understand is that from forests are huge natural resources where the livelihood of certain class of people, they are dependent on them. But then
Yeah.
again, extracting something, it needs to be managed well, which leads to our next question or next topic of discussion, that what are the conventional approaches that we think are good towards forest management? Because I mean, we have seen remote sensing techniques and geospatial techniques used for forest management, but before that, coming to that portion, we need to first understand like what have been the conventional approaches. And maybe Dr. Lin can share his views, like the conventional approaches, not the remote sensing ones.
Well, forest obviously is a very important part of the economy. In Australia, I guess, in Tasmania in particular, one of our states, the government is trying very hard to strike a balance. Obviously, forest there is not only as a carbon sink, but also as a industry. So the logging is a very important part of that. There was a period, obviously there is an overlogging that is going on. So you take out the forest before you have enough supply and stuff like that. And nowadays, as you can imagine, because everything is going electronic, so there's less demand on paper and stuff like that. Hence, less trees will be chopped down and so forth. In the end, as I said, it's a matter of balance. So obviously, we want to make contributions in terms of the CO2 emission. There is obviously not just the forest itself; it's part of the global carbon trading, if you like. So it's not just well, there was the Australian policy to buy carbon credits from, let's say, Indonesia, Malaysia, so that they can have more forests. Back home, we should do that as well. So it's a fine line to walk to make sure we get the balance right. Yeah.
Yes, I totally agree. Dr. Mukesh, would you like to share your views on particularly the challenges of forest management or monitoring in India?
We have forest for the production point of view. We have the forest for conservation point of view, and then we are using forest to protect our soil erosion as well as the environment. We are not doing the uh, cutting tree for the production point of view. So awareness is very, very important in our country, that and the development activities not in behalf of the forest. I still have remembered when I was doing my MS in the Netherlands. I was walking in the street, and some of the people was standing near a tree and trying to pull the leaf from the tree, and some of the local people come and they uh, start giving us the importance of tree and explaining about the importance of tree, and telling them that this is not good to plug the leaf from the tree. So awareness is very, very important in our country, because our forest is considered as the production forest, natural forest. So until unless we will not aware our people or local people, uh, I think it is not possible. And second things, development is very important. I understand it. Development is important, but not on behalf of the forest. So like you can visit Northeast India. A lot of development is going on, but on the behalf of cutting the tree is not good. But overall, our forest area is increasing. If we
we look to the area of forest cover in India is increasing. But I don't have any report of the natural forest right now, but I can say that we should have to protect our natural forest because it's very important for the biodiversity point of view. And my study for the MTech project was also to conserve the biodiversity of the area. So I can say that conserve the biodiversity. For that, we have to protect our natural forest and to educate the people, mainly for the people who is staying inside the forest, the travels people. And then we should also have to arrange the livelihood for them so that they can not cut the forest. They understand the importance of forest. That is all about my idea in context of India.
Sure, Dr. Mukesh. What I understand from you all is, I mean, there has to be a very a fine balance between the natural resource management in terms of forest, and as well as livelihood, as well as development. Because I mean, if the population is increasing, they need space and place to live, and there are industries which are based on forest, like paper industries. So there has to be a balance while managing, especially if you are cutting down trees. There has to be some sort of maybe plant some program of planting the trees as well, so that you can plan ahead in the future, if you want to replace a natural resource which is as important as forests are. Now, which brings us to this next question, that to manage something.
Sir, I would
Yes,
like to
yes,
add
yes, Dr.
some
Chaudhary, please go ahead. Please go
that
ahead.
Mukesh, that question. Sir, if you see that for man and environment balance, we need that 33% of that plant cover or that forest cover. And if of India, so we are telling in that books only, but if you see that latest figure, that figure is that only 12% is forest has been left in India. And
Yes,
and yes. Hello. Hello. Hello.
yes.
Hello.
Yeah, Dr. Pandurang, please continue. We can hear you. Please continue.
Yeah. If we see that the bigger challenge is that if you see that the ST population, that most of the ST population, they are living in the forest areas, and they're totally dependent on that forest area. We have to reduce their dependency on the forest. That is a must. That first thing. Second one is that we have to do that proper mapping of that forest, that we have to categorize that forest. And I mean to say that what type of species are there. And after that, we need to develop that is forest fire, that real-time system for that every area. If we see that the major forests are located in that Himalayas and Western Ghat and Eastern Ghat and some of the patches of the central India. So these are the major challenges in forest management in our India. What I feel that because of most of the people are dependent on the forest, we should reduce the dependency on that forest. So they will stop that cutting of that forest. That is the my opinion regarding this question.
What I would like to say, sir, in 2005 I was working with the Forest Survey of India. That is the nodal agency who is doing the forest cover mapping as well as the forest type mapping of India, and they have published the report in 2 years interval. So on the basis of that, we can say that we have the 33 or 34% of the forest. And I have visited many part of the forest like Jharkhand, Chhattisgarh, that was my area, and all the mapping was done by the satellite data. So we can not say that no, we don't have that much forest. We have it. Maybe like many places in Jharkhand and Chhattisgarh, some afforestation program is also going on. But my concern is, afforestation program is fine. I'm happy that the afforestation program is going on. But as Deepak sir has told that, does it help the conserve the biodiversity? I think no. So we have to protect our natural forest, and definitely we can go for the alternatives. That is fine. That is I'm agree with you that we have to arrange the livelihood for the SC/ST population or the
Yes.
people who is living. But the Forest Survey of India is doing forest type or forest cover map on the basis of the satellite image. That time they were using the list 3 data, that was 23-meter spatial resolution. But right now, I think they are also using the same resolution data. So definitely that we have to find out some alternative to protect our natural forest. That is, I agree with you. But the forest.
Okay, sir, if you see that it is if you see that state wise that forest cover, no, it will be different for all over that all that states of India. If you go in the northeast,
that is correct.
you will find that a lot of that forest cover will be there. If you come to that southern India, then the forest cover will be different for that as per the area, or maybe that as per the state.
Yes, yes. I think we are going to get back on that topic more, how the geography changes, how the land use changes with the region, because I believe the state of Maharashtra is lined up with the Western Ghats as well, and all those natural resources, huge natural resources. At this time, I would like to take views from Dr. Tao, that we have seen that Piesat has developed a very it looks like a very efficient platform for forest fire monitoring in near real time, and obviously the inventory and all those related aspects of forest management. So Dr. Tao, what do you think, that India is ready for such system?
Thank you very much. Actually, due to the big progress in the research conducted by Professor Ning Ning and also other researchers, we have a lot of technology available for the forest fire detection monitoring technologies. For us, what we are doing is we're trying to turn this technology into the operation systems. So we developed the platform to provide a near real-time service to the what they call application side. And this system has been very successfully applied in China. We are doing the test with the Professor Ning Ning in the Australia right now. We also had some contacts through the Mr. Sanjay in India. But the problem is for us is because we need to know what's the real needs for the forest fire in India. We need to customize our system to meet maximum for the India case. That is one question we would like to ask our India friends. What kind of a service in the forest fire service you are much interested in, and what kind of value you are expecting through our platform? This is a question. For us, we are technical ready, and we are also building the business channel, business platform for this service. So a question maybe I would like to give to our Indian friends. What are you looking for this kind of service? Yes.
Sure. Thanks, Dr. Tao. I think the floor is open for our participants, especially all the Indian participants. If they think, if they have some ideas, like what they would like to see in a forest management, a comprehensive management platform, apart from fire monitoring or inventory, they can share their views, and we'll just wait for a few minutes. And before that, since we have Dr. Lin Lin, I would also like to ask him that how remote sensing and GIS is contributing towards this entire forest management aspect as compared to conventional approaches.
You want to hear from me first or from the audience first?
I think we are taking questions from audience, so we are just gathering them. Mr. Sanjay is gathering them.
Yeah,
So first we
sure.
would hear from you, Dr. Linen.
Yeah, well, both remote sensing and GIS, as you can imagine, are extremely useful tools when it comes to forest management. There's no doubt about that. I perhaps even want to emphasize more in terms of remote sensing. So we've seen some sort of transformational technology development. If you think about, even the private sector that is playing such an active role in remote sensing, because the affordability of supplies is just getting better and better. And of course, both India and China are very strong players in the space sector. There's no doubt about that, and contribute very positively to that. It's very much the last slide towards my talk that I mentioned, just touched very briefly about constellation. So as you might have realized already, it depends on the type of application. Obviously, I love the chair, the MC just said. Forest management is obviously much larger than bushfire itself. So we can talk about applications in two very different categories. One obviously is time critical, and that's fire management and stuff like that. The other is the more ongoing, the day-to-day management, and of course, long-term management of forest. Because we have much more affordable imagery, and indeed a diversity of imagery as well, my favorite topic is how we can combine and indeed get the best value from combining radar and optical. Let's not forget there are places such as Indonesia, a lot of tropical regions. Cloud cover is always a problem. So if you rely too much or rely only on optical, then you won't get the information you need. Also, there are active research in the area of how to measure the forest, the height of the trees and stuff like that. Obviously, we can manage forests much better in terms of when they are mature enough, we harvest, we log the trees. Optimizing the allocation of resources and stuff like that. So there is a lot to offer. Something that I want to emphasize is also Piesat obviously is in a very unique position because they've been in the remote sensing business for a long time. They have their in-house software, very significant IP around that. So obviously they have a range of partners such as us. So I think it's a perfect timing for us to think about that. One thing that we take it for granted is also because the resolution is getting better and better. And hence a lot of the stuff that you can't do right now, we pretty much almost down to a single tree, that kind of resolution, because we're talking about, the tree canopy might be a few meters, but right now, sub-meter satellite imagery, ultra high resolution imagery is also available on a routine basis, affordable as well. So yeah, that's my take.
Sure, Dr. Linen. Yes, we do agree that the remote sensing data and the GIS technologies are getting more convenient. We have more data, and one of the best advantages of a simple data as such satellite image is that not only we can do a near real-time analysis on monitoring, we can always go back in past or retrospectively we can analyze the pattern or the trend which we can use for predictions, future predictions as well. I would also like to hear from Dr. Lee Jia about what he thinks of involving remote sensing and GIS in forest management. If we have Dr. Lee Jia, if he's still online. So while he comes online, we can start taking questions from audience. Mr. Sanjay.
Yeah, we have some questions from audience. Dr. Lal, if you can see the WhatsApp, there are some questions I have shared with you.
Okay.
On behalf of the speaker.
Sure. All right, I believe one of the questions that I came across was about this presentation made by Dr. Mukesh, where one of the audience was asking that whether 1 year data was enough for validation. So what are your views, Dr. Mukesh?
uh, like as we are doing the forest fire mapping of particular year, definitely if once we are creating the database, we are creating the database for the one particular years, like for the elevation, slope, aspect. So the database base should be of for the 1 year. So we can do the continuous monitoring also. It is not something like we cannot do it here. But when you are creating the base map, so base map is like if we are creating the land use land cover base map of 20 and then other databases from the previous year, it will not work. But when we are creating the same database for the forest fire monitoring, once we have the database and then at the same time, like we have the database from the Modis dataset, 1 year data is we can do the validation, because it is not the continuous monitoring as like Piesat have give us opportunity. Maybe in the future they will give us opportunity to do the continuous monitoring. That forest is coming to particular places that's increasing or decreasing or something like that. So continuous monitoring, like Modis definitely is doing it, but it is not giving it as like I have seen it in the presentation of Lin, which has been like supported by the Piesat software. But definitely when we are doing the validation points should be collected for the same year, the data for the year which we have creating the database. So that is all about this.
Thanks, Dr. Mukesh. I think next question is for Dr. Lin. If he can answer, what are how the physical characteristics like lineament, geological faults, and some of the attributes that can lead to this forest fire studies? Are there any indicators, as I understand from the question?
So if I understand the question correctly, it's about different types of vegetation.
Are there any physical indicators, Dr. Lin? I'm talking about like, are there any physical indicators that can lead to, when we are trying to locate that this is more susceptible or this area is more prone to fires? Are there some indicators to it?
Yeah. Yeah, I think my kind of understanding of the question is correct. I don't know if everyone know, in Australia, there's a particular type of forest called the eucalypts. So it's actually very flammable compared to a lot of other vegetation. So that goes back to the mapping of the forest and then the forest management. We obviously love to have a very detailed inventory. And in that case, we can do a fire modeling better. Obviously, different forests, different types of vegetation have different vulnerability when it comes to fires and stuff like that. Other effects such as obviously the rainfall, the soil moisture, and so on and so forth. So in that sense, when you try to manage forests, you can't just think about trees. It's actually the whole system that they need to think about.
Sure, Dr. Lin. Thank you. Dr. Tao, would you like to share something about the technologies that are that we were discussing and that are available, some of the best technologies for forest fire mapping?
Okay, actually, technology.
We are coming back to this topic with you.
Okay, so a lot of new technologies coming, and like the very high resolution SAR satellites. Actually, our company Piesat is also planning to launch this kind of satellites, and in the coming years, if the data is available, might be a good big contribution for this kind of research. Other things might be, I'm thinking like the drone, because it's a very economic way for the developing countries. Combined with drone data would be provide some kind of economic way for local operations. And for software parts, because a lot of new technologies like the AI and other things, we are also turning into the operation package in our software. We can combine the software methods to process the data in a very efficient way to get more information to support the decision-making process. This is what I am thinking currently. Yeah, thank you.
Thank you, Dr. Tao.
Dr. Lal sir, if you don't mind, can I add something?
Sure. Go ahead, Dr. Chaudhary.
Sir, your question was that what are the data set or the parameters which are needed to predict the forest fire? You mean to say that?
I mean, it was a combination of some of the physical features as well as what we can, how we can use remote sensing data to identify those features, or what are the features which can lead to identification of fire prone areas.
Yeah, so there are other means that other parameters like that air temperature, then relative humidity or elevation, or
Yes,
maybe
like
wind speed.
one of the participants is asking how, what is the influence of the soils on
Yeah, there's definitely,
fire?
sir. I would like to add something because of if we add that soil moisture data in forest fire prediction, that will be good because of it gives the actual condition of that soil. And if that soil is getting dry, it will be a lot of chances of that forest fire. So that soil, that moisture is also playing a very important role in forest fire and that forest fire.
Sure. So I think taking lead from what Dr. Tao has said, that the technology are coming up. There are various available technologies, and there are technologies that can be customized to monitor, to manage forest, especially forest fires, in a very efficient way. One of the most important technologies or tool that we can see is upcoming technology is drone. So I'm very happy to take this opportunity, and before we end this webinar, I would like to announce this course, which is will be jointly organized by Schwartz and Piesat. I'm going to share the screen and I'm going to reveal that course. All right. So Schwartz, in collaboration with Piesat International, is announcing an integrated drone training program. It will be a two-fold program. The first fold, or one of the objective of the program would be to target people who are already working, who are in their jobs, and they would like to get trained for drone operation. So there'll be a program for that, or they are seeking an individual certification or program for drone training. There will be a program for them, and then there will be an integrated program as well for the students who are already pursuing their degrees in various areas like civil engineering, agriculture, forestry. So they can earn this certificate as well. They can learn how to acquire drone data, how to process it, and how to use it for their different purposes. So we have planned this program accordingly. It's highly customizable, and it will have a lot values, as we are seeing that the drone market is growing by leaps and bounds. So for further inquiries and admission, you can contact me or Mr. Sanjay itself. And I would like to invite Dr. Tao, if he can share his views on this program as well.
And Piesat has a subsidiary company which is manufacturing drone, and in our software package we also have a module to process the drone data. We call the PIE UAV. This is a base we can cooperate with University of Schwartz. we can share this technology, both of the hardware and the software, to meet the education purpose, for the education purpose, and also for the career training purpose. And this program actually will try to start as soon as possible. We are getting very close to launch this program. And hopefully, we also hopefully get the support from our India society. If you have any what they call requirements, please be free to contact with Dr. Now, Professor Now, and also Ms. Sanjay. We'll try our best to serve you where best. Thank you very much.
Thank you. I would like to add something on behalf of Piesat India. As we can see, the collaboration for announcing this particular integrated drone training program. Along with that, the second phase of the training program will be basically for the drone pilot training program, which is the larger venue, I believe. And as we all know that the drone market in India is basically growing very rapidly, and we do not have especially in our country, we do not have the skilled manpower especially into the drone segment. And I believe that the announcement of this particular course will help the people to become more skilled into the particular domain in the country, and more people will be contributing into the different organizations in the country as well as the out of the country into the particular segment. And I am really thankful to Suat for giving an opportunity to Piesat International to join hands to start this particular program. Thank you, Suat. Thank you, Dr. Deepak Lal.
Thank you, Mr. Sanjay. I think it was a very fruitful webinar, and we would like to thank from both Schwartz and Piesat, Dr. G. Linlin, for sharing his views and presentation, very informative, and there was so much of information in his presentation. We would also like to thank Dr. Mukesh Kumar for sharing his research on forest fire mapping, Dr. Lee Jia for telling us about the platform that Piesat has developed. Then we would also like to thank Dr. Pandurang Chaudhary from University of Mumbai. It was a great pleasure to have you, Dr. Chaudhary, and we look forward for organizing more webinars like this and having you all here. And lastly, I would really like to thank Dr. Tao. He is always energetic. He is always present in our webinars, and it's great to have him as well. So thank you, sir. And with that, I think our next webinar will be also on natural resource management. We would decide a specialized topic and we would share it on social media, so you all can have an opportunity to join in the next series. And with that, again, thank you very much. Stay safe, and we will see you all next time. Thank you.
Thank you.
Thank you, Lal sir.
Thank you, everyone.